Hey guys, welcome back. We're going to cover section B today in chapter 4. So we're going to continue talking about the periodic table, okay, and just kind of how to find the patterns in it. This is a periodic table, and this is actually a pretty basic one. There's not a lot of information on the actual squares, but we can see how the groups. Whoops, let me go back and get my pen here. There we go. So these groups or families are numbered, okay? Remember, those are the vertical columns. So you can see that there's 18 groups or families, okay? And they share the same number of valence electrons. And you can see that they're also named different categories according to those families because they share so many similar properties. We also have the periods, which are the horizontal rows, and there are only 7 of those. Keep in mind that these down here really fit right here in the periodic table. So this lanthanoid series is part of period 6, and this actinoid series is part of period 7. And they have the same outer energy ring for their electrons. Okay, that's what those share in common. We're going to talk about some of these as we go. There's a couple different ways to label these groups or families. We're going to talk about some different ones, okay? But first, there's basically only 3 types of elements. About 80% of them are metals, okay? And these metals are solids. They are malleable, which means they can be shaped. They are ductile, which means they can be stretched. They have high conductivity for both heat and electricity. And they're pretty reactive with nonmetals, okay? So about 80% of the elements on the periodic table are metals. They're not always shiny, though, which is interesting. That's kind of a assumption we make about metals. A lot of them are, but not all of them. Metalloids, okay? Metalloids are these funky elements that kind of, I don't know if you can see that over there. See where the blue meets up with the red elements right there? There's kind of this stair-step set of elements there. Those are the metalloids. They're solid, but they're very brittle, unlike the malleable and ductile metals. They might look like metals. That's actually a picture of a metalloid right now, but they don't act like metals. They're not as conductive as metals. Their reactivity totally varies, and it's just that brittle nature that makes them not quite like metals. But since they share some of the characteristics, they're called metalloids, and there's only a few of those. And then the rest are nonmetals, and that's our gases and our liquids. They're very poor conductors. Their reactivity also varies. Now, there is one exception to this for the metals. Mercury is actually a liquid, and it still is considered a metal. So not all of the liquids are automatically nonmetals, okay? And you can kind of see the breakdown here. So all those yellow elements are metals. That purple, again, here's our little stair step kind of here. Those are our metalloids. And those are really separating our metals from the nonmetals. Hydrogen up here by itself, you know, if we're lumping it together, it really is more like the nonmetals over there. But we don't do that because it has one valence electron like the rest of the elements in its family there, okay? All right, so let's talk about these families. There's different names that we can use for those. The book lists them all out for you, and it gives you some properties. So if you start on page 82 and kind of go through, you can see a lot of those. The first one, so the family number 1 right here are the alkali metals. They only have one valence electron, which makes them very reactive. They want to give that electron away so that they can get down to that more stable inner ring of electrons, okay? Right next to that, we have what's known as the alkaline earth metals, and they have 2 valence electrons. Those things like to react with both of these groups actually like to react with things over on this side of the periodic table, okay? Then we have the transition metals. The transition metals are all those blue ones in the middle, okay? These are all the transition metals. The book will then talk about the inner transition metals, which are all these down here, and then the post-transition metals. Those are those metalloids, those are those metals that are kind of on this area before you get to the metalloids, okay? Then we have the metalloids. And then we have the nonmetals. We already talked about those. But then we also have the halogens, which is this column right here, and the noble gases. Okay, these noble gases have 8 valence electrons, which makes them incredibly stable, which makes them very non-reactive. Okay, they already have what they want on their outer shell, so they just kind of don't play well with others. Okay, let's see. I want to see if I can get this to work. Let me go back to my mouse. There we go. I'm going to take you guys to a website. We'll go through this in class. But this website is a really good breakdown of all of these different families as well. Okay. And it'll show you that you can name these different ways. You might just want to refer to the basic 5 there, the alkali metals, the alkaline earth metals, the transition metals, the halogens, the noble gases. For our purposes, that's probably enough. These specific families, though, that are listed in this 9 elements, the book does get into. On page 84, it starts to talk about these mixed groups, okay? And that's groups 13 through 16. And they're named according to their, I wonder if my pen will work. Look at that. They're named according to their very top elements. We've got the boron group, the carbon group, the nitrogen group, and the oxygen group. And it's a mixed group. They contain some metalloids, they contain some metals, they contain some nonmetals. They're just named according to that element up at the top, okay? Now I've got that pen there. Oh, let's erase it. Oh, come on, erase. Oh, well, doesn't matter. It's not going to erase. I'm filming. That was Mr. T. He just came in. Anyway, those different families or groups have lots of characteristics in common. So these alkali metals, they're soft, they're shiny. Like I said, they only have 1 valence electron. Those alkaline earth metals, they're still solids. They're somewhat shiny, just not as much. 2 valence electrons. All these transition metals here are also metals, but there's not as many things in common, okay? There's just kind of a larger chunk. They're not as reactive either. There's the boron group, starting with boron, 3 valence electrons. There's the carbon group, 4 valence electrons. So you can see we're counting up 1 as we go across until we finally get to the noble gas family. There we go. Let that picture load up. 8 valence electrons. They are considered an inert gas, meaning they just don't react, okay? And that's where things like helium and neon and argon and xenon, these funky gases that kind of glow at different conditions, but they don't react with other things, okay? All right, I believe that is all I've got for you. Have a good day.